Hey, awesome folks. How's it going? It's the last technical stream of GHW. How do you all feel about that? Hi, Pradumna. Welcome back to the stream. How has GHW been for y'all? Any favorite streams yet? Any feedback that y'all have? We have just one more mini event to go before the closing ceremony. I'm glad you enjoyed it, Shamari, and I know it's very late for you, so I really appreciate you being here. Monday work day it is, but welcome back, Evan. I'm so glad you're able to join today. So, folks, what all did you learn in this GHW? Is there anything specific that really made you change your mind and go, okay, this is something I can try, or hey, this was probably easy. I should have tried it earlier. Anything new you learned? Anything? It does not have to be technical. It can be as simple as being able to use the Twitch chat. It took me a long time to type anything in the Twitch chat. I'm so glad you learned so much from my stream, Shamari. I am already working on the next GHW content. So today's session and yesterday's session will be way more hands-on and will fit the theme also of data engineering. But yeah, today is again a very simple thing we're going to do. No hands-on. You all just talk to me. We'll basically have a lot of discussion on what is what. And we'll go over some tools that you can use, you may want to use. Nothing hands-on, very short session also. And yeah, we'll just have fun basically. So we to the point. I have recently gotten into this landscape, and yeah, I love that suggestion. I absolutely IoT Iguana does sound good. I'm gonna have to get it out of Partners Fair Village to make sure that they have enough IoT theme. But we can manage that. We have a year to get partners and sponsors on board to make it an IoT year. I am soon joining a company where I'll be going to office every day, so I'm gonna miss work from home. I already miss work from home. Hi Alok, welcome to the stream. It's a small crowd today, which is amazing because now I know who's there because most of you all have replied, and you all know I pester until I get answers, right? So it's gonna be nice and simple. But yeah, I'm glad you all have been enjoying GHW. There is one Chrome Diner event still left, which I completely recommend you all join. I'll try and drop by, but I might head out. So and so. But is there anything y'all want to say or discuss before we start today's topic? It's short. We have enough time to talk about the smallest things that y'all might want to. So let me know if y'all have anything that you'd like to talk about. Alright, since I do not see any answers, I'm going to start sharing my screen. Alright, Observability 101. Simple yet such an intricate and beautiful topic that I absolutely have been, very caught up by it. Let me quickly, so remind me folks, in case I forget, I draw a lot of my content from this book that I've been reading. I'll drop the link to that book by the end of the session. But yeah, an amazing book. It's usually it's one of the top read books for observability, and it's genuinely pretty well, it's like a very superficial layer of book in the sense it's one of the first books you want to read if you're just getting into observability. So, right, awesome. Let's move on. Let me find my PPT. All right, what questions are we answering today? This is again one of my favorite Google themes of the recipe book, which is easily available. I just love this theme. I cannot get enough of this theme. If you all do get tired of it, let me know. I'll go hunt for a new theme, but this is so nice. Okay, cool. What questions are we answering today? Okay, these are the questions that we're answering today. I'll give a quick introduction for anyone who's joining for the first time, although I can see most of you already know me. What's observability for folks outside engineering? So it's and when I say outside engineering, I don't mean people who are not engineers, but people who are outside software engineering. People who, like, for me, basically that's the first definition I would have wanted to get started with, right? And then it's for engineers, basically people. So it's that's the definition for folks involved more in SRE, DevOps, and understand the need for it already, basically. All right. So let's get started. Answers. Okay, so this is I haven't added all the extra slides I usually do about we are live and the first what is observability question slide. So we're gonna stop here and get started. All right, folks, we are live. So I want you all to go ahead and tell me in the chat what do you think observability might be. Again, this is not you're not supposed to know the answer. You're not supposed to even tell me the technical definition. You are supposed to tell me what you think might be. You can give me funny analogies. You can give me, what I think observability is, and so and so. And it's the first thing that comes to your head, the first image that comes to your head. Go ahead, put it in the chat. Yeah, Shamari, you do not need to know what's observability. You need to tell me what you think it might be. Remember, it's our intuition exercise that we're doing. Okay, this is what it might be. And once you do that, I promise you, you'll be able to remember everything ramble on better. Make sense, folks? So just whatever comes to your head. Okay, observability might be this. It can be compared to this, like whatever comes to your head. I'm going to give you all around 4 minutes. It is 10:41 in my clock. Let's see if you all can come up with some creative and rather funny answers in 4 minutes. That is an amazingly accurate answer, Brinda. And welcome to the stream. I haven't seen you answer before on chat, and I do remember people who answer. But that is a little too accurate, and I have a feeling Google was there. But I'm glad you put in the effort anyway. That is a great correlation, Shamari. Observable plot. All right, so we're trying to observe something, and we're trying to plot something that we can observe. So close enough. That's a great answer. All right. Anyone else want to give it a go? Brinda and Shamari did a great job. Ahmad, Pradumna, would you all like to try? What observe? Oh, you worked with Open Telemetry, Brinda. That is amazing. Do you have a project or something that you've done that you'd like to show? Or do you have a GitHub repo that you'd like to show where you've done Open Telemetry? I'd love for people to have more real-time examples. Hi Ashutosh, welcome to the stream. Alok, are you trying to answer as well? I'd love to see what you think about what might observability be. So Ashutosh, there's a question for everyone in the chat who's joining us. What do you think observability might be? It does not have to be correct. It does not even have to be remotely near the topic. Hi Anudhyan, are you going to try and answer the question that I've asked? That is very cool, Vrinda. You're welcome to come on stream and talk about it if you like. Amazing. I love this answer. Some sort of logging and then drawing insights from it. That is exactly what I need you all to. Just vague correlation. Perfect, folks. So since you all have given such great answers and I can see that it's a Monday morning and you all are still kind of, getting started with the day, I'm gonna go ahead and answer the first definition that we might. Oh, I never introduced myself for people joining me, but I think most of y'all know me. Hi everyone, I'm Rithvi and I am a coach at MLH, and I've given more detailed introductions in the past streams that you all are welcome to go look at. This is another very pretty picture which I like to put on my slides. And what is observability? Cool. For everyone, one, observability is actually a measurable quantity. Can you believe that? Observability is not just about observing, but it's also measurable. All right, then it is more than just a status. It is more than that. Okay, can I observe it or not? Right, it's way more than that. It is a very layered process. Why is it a layered process? Because we're not just observing a system. We're not just observing uh, Precisely. Observability is a system to collect data and its runtime behavior. But it's more than just data and runtime behavior. It's about collecting data from every layer. Hence, it becomes a very layered process, right? Because we'll get into why the need for observability came and how it happened. But I like to, like I said, right, analogies are a great way to compare this. Fast fashion is a great example. Why is fast fashion a great example? Do you all know how fast fashion works? Raspberry. Oh yeah, I like these berries picture in the thing. I love the sarcasm here. Is that sarcasm? I'm not sure. Are you genuinely asking the question? I on chat it can be a little difficult to understand. But yeah, I hope that was sarcasm. And fast fashion is a great example because I don't know if you have been reading articles about their, so it's bad for the environment, yes, but their processes are very, very, appreciated in terms of how efficient they've made it, right? So fast fashion, what they're doing is they're collecting data continuously from so. Okay, I'm glad because I can never tell. I was like, okay, Shimali is really tired. The sarcasm is pouring out, but no. So fast fashion is basically your brands like H&M, Zara, or Shine, right? They're all examples of fast fashion. Fast fashion is basically you getting retail outlets, so new designer outfits becoming retail outfits very quickly, and then going out of the store very quickly too, right? So fast fashion, what how it works is they're collecting data continuously. So every time you visit their website, how much time you spent on what product, what you added to the cart, etc., etc. On top of that, they have to keep up with the new designs. So they're constantly looking out for new designs, what designs influencers are wearing, so what brand influencers are wearing, and all of that chained together. They decide what cloth to basically make, what design to make, and then they keep a lead on their stocks as well, and then based on that produce more and send more for manufacturing and production. You can see it is very complicated, and there's no monitoring happening. You see, there's observation happening every time you're spending time. There's a metric that's getting updated, and constantly they're kind of they have an algorithm to kind of keep up with it, right? So it's more of an analogy. It's not exactly the same. It's not even remotely the same, but it's a great way to understand what's happening. There's so many layers, there's so many channels, and you're kind of trying to keep a tab on all of them, and trying to produce and work on the feedback that you're getting from all those layers immediately. Make sense? All right, thank you so much for clarifying. Kind of with trends, right? It's not just trends though, it's trends that are actually flowing into different age groups, different kinds of demographics, so people who travel, people who don't travel, etc., etc. Make sense, folks? Awesome. So that was just a very basic intro. That's a very gentle intro. Okay, this might be what observability is doing, but it's actually way more, layered, and basically it's very pretty. Its origin, right? So let me pull up my. Okay. Mm. So observability was actually coined. The word observability was coined by the engineer Rudolf E. Kilmagen. Yes, it is that, but it is way more than that, right? It is that plus the new designs coming out, plus what stock is clearing, plus what stock is actually in the cart but not really clearing. So there's something wrong with it, right? That people want to buy it but aren't buying it. And all of that, and on based on all of this, their manufacturing decisions are made. So that, let's say they send a manufacturing point today, you can get it in stores by say 2 weeks, 3 weeks. I think the fastest lead time is 3 weeks. So even after being so fast, there's so much more, right? This logistics. So let's say some country from the manufacturing house is takes 3 weeks to just get the shipment. You know that they're going to be observing that region more aggressively so that they can make it on time. Make sense, folks? Alright, awesome. So let's talk about the origin story. So the term observability was coined by Rudolf E. Kilaman back in 1960. Alright, it has since grown to mean a lot of different things, but actually it was a characterization in his paper, a mechanical paper on mathematical control systems, that he used the word observability. So, in control theory, observability is defined as a measure of the internal states. Okay, so from its external outputs compared to the internal states, there's a mathematical formula behind it, which is called observability, right? So it's actually controllability as mathematical duals. So output versus internal states, right? So this comes along with sensors, linear algebra, and the formal methods that go on and on if you're studying mechanics, right? So if you come from a mechanical engineering background, or if you're into mechanical engineering, you have a very different meaning of observability. All right. So is that anything related to what we're going to be doing right now? No, right? This is how the word came into being. The software adaptation of this is fairly different, but the entire idea behind it is the same, which is why the word kind of transferred on, right? You basically want to know the internal workings of your system or your application. You want to understand the state of the application that might have gotten into, a rut, or you want to see if it's reaching new states that you want to where it would reach, right? Because we'll see how, we had to diversify from metrics and monitoring into observability. They're not the same thing, right? So we should start by knowing that, okay, they're definitely not the same thing, right? So why do we have to, have some custom code on top of our, usual code to handle observability, right? So think of it this way, right? Let me just quickly check. I think we can go on to the next slide. So there you go. We're going to be covering this right now, all of these weird words and everything. So if you recognize any word, let me know. If you have a better explanation for them. But this is basically what we're going to be covering, right? So these are for engineers. These definitions on the right are for engineers who are, acquainted with a lot of SRE, DevOps, or basically metrics of a software application. I don't expect anyone here to know any of these words, or at least, most of these words, because even I'm not from a software engineering background, even though I've worked on a production code base, right? These are things that you do not have to concern yourself with as a coder for the most part, right? So these are very, okay, are we using the resources well? Oh, the only word you're not familiar with is cardinality. That is amazing. So yeah, cardinality is actually the crux around which observability is based, which is a little sad. But if you understand all the other words, Shamari, getting hang of cardinality is very easy, right? Okay, so let's talk about the three pillars of observability. Any observability definition you pick up, right? Any YouTube presentation you pick up, this is always how they're going to start with. All right, so they're going to start with observability has three pillars: errors, traces, and metrics. And logs are kind of there because they're kind of what give you all these three. So there's something called MELT, right? Metrics, errors, logs, traces. That's your observability entire stack, all right? So that's the first thing you want to know, that observability does not really work on your code base as much it works on the working of your code base. Does that make sense? No, logging over here does not. No, there's no cloud logging here, and I'm not sure what you're asking in terms of cloud logging. But no, logging over here, logs over here mean your trace logs, your error logs, your metric logs. So logs are anything that basically tiny actions that are being kind of noted down by our system. Make sense, Anudhyan? Yep, right. So those are the three. So your logs can be anything: error log, trace logs, deployment log, anything that your system is logging. Observability is going to be a huge integration there, because it's going to make sure it's taking into consideration what is being logged, how often it's being logged, any anomaly it can detect because of the logs pretty much in advance. Okay, so logs are important, very important to observability. Okay, then let's talk about dimensions and cardinality. All right, so a single number with tags optionally appended for grouping and searching those numbers is basically what is cardinality. All right, so let me quickly pull up some text for me. All right, okay, before I move on to discussing this more, can you all tell me how, now that I've said so much about observability, how is observability different from monitoring? And one of you all asked me about time series database versus real time database yesterday, and this is the answer to your question, right? A real time database is a logged in real time database. A database can be against anything, right? It can be uh, the number of parameters, everything is very flexible. However, in a time series database, everything is against time. So a lot of things are monitored against time. So can you all tell me why metrics weren't enough, or why do we need monitoring in the first place, or why do we need observability over monitoring in the first place? Can anyone take a guess? I mean, we are monitoring. There are tons of ways to monitor. Anything that you use, any resource that you use comes with a pre-tool, like a tool with it to monitor what's happening, to be able to tell if there's a crash, an error. Why do we need to observe a system on such a level, in such depth? I'm going to give you all 3 minutes to think about it. Okay, that's a good question. Monitoring helps to check the CPU usage, correct? Right? But why observability? If you can monitor and get a lot of answers, why observability? Precisely. That's the end point of everything we do, right? But why did we have to add observability on top of monitoring and metrics? You already had that, right? What could have been possibly going wrong in these basically Okay, Shikha, that's a great answer. To gain some analytics or derive a conclusion related to the system. Alright. I'm going to give you all a hint, right? Monitoring and metrics always give you conclusions and tell you about the behavior of the system after the event. What is observability doing that is making it report to you before the event rather than after the event? Come on, folks. That is that is smart, Shumari. Thank you very much. Precisely. So the problem here is that metrics is not enough. Why is metric not enough? Because as we go further into uh, the technology evolution, systems get more and more complex, right? They're not complicated, they're complex. What is the difference? That means there are multiple services running, right? I mean, first there was microservices that came around. Then there's an entire orchestration tech that exists just to be able to manage those services properly. Then there's something called observability that had to be added onto the entire tech stack to be able to see, because the system is so complex, when errors or anomaly happen, no one, especially the engineers, can't predict how it ended up there, right? So what observability does is it has a way of kind of processing the data that it's receiving from so many logs, and being able to run algorithms that it can predict the states. Or if it could not predict the state in time, it can definitely help you solve it by showing you the error region immediately. Monitoring and metrics will never show you the error region. It will show you that okay, there's a problem. Where, how, you can never have any idea until and unless you actually sit down and do a lot of manual testing, or manually run a lot of specific tests to understand what's happening. Make sense, folks? Does that make sense? Yeah. So let's talk a little bit about how the word metric was born, right? So in 1988, there was a simple network protocol, right? Simple network management protocol, and the foundational substrate they in that network protocol introduced the word metric. So what's a metric? A single number with tags optionally appended for grouping and searching those numbers is a metric. Okay, so does that does that give you a good idea of why metric might not be enough to tell you the problem region? So it's a single number, okay, and it has been appended for grouping and searching those numbers along with the tag, right? Make sense, folks? All right. So, as tech has evolved along with metrics, there was a lot of things that came into being, right? So, a metric also takes up a lot of space, right? Because it has to have a lot of storage in it. Because a metric is then put onto graphs, and then these days you get more sophisticated like time series databases and statistical analysis, graphing it. Even then, you need to keep storing it because it's a huge number, first of all, with tags and multiple things attributed to it. So it has a huge storage footprint, right? Plus, it's still not telling you the error area. Now, remember, depending on your application, monitoring and metrics are still a great idea to have around. Based on your deployment and has extra tools to just keep a tab. It's a great tool to have around. No one's telling you to get rid of metrics or monitoring, right? We're saying that metrics and monitoring aren't really solving the crux of the problem here, right? So what do we do next? We got observability, right? So when can you not use observability? I told you what observability is solving. So when would you use observability and it would fail or it would really not do any good to you? Can you all give me an example of when observability would basically be a bad option or a bad idea to implement? It's 11:02 in my clock. I'm going to give you all 3 minutes to answer this or come up with answers for this. Precisely, that's a great answer, Shimari. So you do not want to use it in what's called a monolith, right? If your application is not running tons of microservices, or it is basically a monolith, you do not need to use observability. You can, but it's really not really going to help you a lot. Precisely. That is a great answer, Vrinda. Vrinda already knows this. Vrinda, you're welcome to come on stream at any point and talk about your experience, okay? Just create a ticket in Discord and I'll send you the stream link. Uh, there is less stateful data. So that basically, even if it's a complicated services, the internal states aren't changing that much. Now, I don't have a very valid example or a relevant example to give you all here in terms of application, but basically, your internal states are just there to kind of communicate with each other. So again, not really the number of services here that should be a concern, but the states of the services, how fast they're changing, and how many permutations and combinations will basically let you to decide whether or not you need observability. If there are like 4 states that it's reaching max, that is a very very random number. You can basically predict it, and you can predict this for a fairly high number of states, right? And put up a lot of algorithms for testing. We're talking about, absolutely insane number of services like Netflix, or basically, where a lot is happening, where you're looking at user data, where you're looking at, streaming, you're monitoring a lot of things from region to like the list goes on, right? So only then do you actually want to use observability, and depending on the scale of your application as well, right? Uh, then the another reason why you do not want to use observability. So let's say you do have a fairly complicated application, but it's not scaling a lot, right? So you have the metrics that even though it's a complex system, your low level metrics are very easily visible. So you don't need observability there, right? Alright, so that is pretty much it. And basically, the more you can think on these lines, right? Complex system but low scalability, high scalability but less number of states, static nodes not needing to be monitored. Like basically they have a very small task and you can just by looking at them tell whether or not they're working or not, etc., etc., right? That makes sense. Okay, one of the major reasons or one of the major, when it's a polyglot system, right? What's a polyglot system? When you have tons of databases and backend services running at the same time. All right, and there are a lot of application triggers that are not in your direct control. That is when you definitely want observability to be able to predict or tell, okay, this is what's causing the error, right? So we already know that the major difference between observability and monitoring is monitoring might be able to tell you that something's wrong. Observability can also point to you that, okay, here's your problem area. All right, folks. Same page, everyone? All right, folks. Let's come to cardinality, right? So this third sentence in the middle row is basically why you need observability, right? So for every application has an inherent amount of irreducible complexity. The only question is who will deal with it, right? Is it the user? Is it the application developer or the platform developer? That is why it's an entirely different thing it's an entirely different team of engineers from SRE or DevOps. Does that make sense, folks? Because these problems that are arriving, is the user supposed to handle them and fix them? Okay, I just change my, how I approach. So it's a button that's crashing, or it's some system that I'm not able to, navigate properly. Do I need to get better at navigating it? Is it the application developer? Does the application developer need to change the code, or is it the platform developer, the SRE and the DevOps folks who need to, basically change the way they're approaching the entire problem? Who needs to basically deal with it? So observability actually points out that, okay, here's the problem area. Go fix this. All right, folks. Now we're going to explain what is cardinality, right? So cardinality actually refers. Oh yeah. That's supposed to be like, worst. If let's say it's a really important application, like a banking application. It can be a terrible application, but you'll have to end up, getting used to it, right? So that it's more of a, you really want the user to deal with it kind of a tone rather than make the user deal with it. But yes, right? All right, folks. So cardinality. Can you all guess what cardinality might be? It's okay. I don't want you all to Google. Okay, so cardinality refers to the uniqueness of data values contained in a set. Alright. Low cardinality means that a column has a lot of duplicate values in its sets. High cardinality means that there are large percentage of completely unique values, right? So a column containing a single value will always have the lowest possible cardinality, and a column containing unique IDs will always have the highest cardinality, which is how you know that always the primary key or the primary key of your any table is always supposed to be high cardinality. It's supposed to have the highest unique values, right? All right. So for cardinality is very important for basically observability. Let's look into what is dimensions. What do you think are dimensions? Can you all tell me what are dimensions? So, while cardinality refers to the uniqueness of values with your data, dimensionality is the number of keys within that data. In an observable system, telemetry data is generated arbitrarily for a structured event. Okay, what is telemetry data? All your logs and everything that is being sent to your observability processing is basically your telemetry data, right? So you sending your logs, you sending errors, you sending trace codes, all of them come under telemetry, right? So we have entirely different tools to do telemetry well. All right. So these events are described because they should contain hundreds or even thousands of events, right? for key value pairs. So every key value pair is a dimension. Make sense? So all your observable data is in a form of dimensions. So what is observability finally is your last statement on the right on the slide, right? Comparing high dimensionality data and a high cardinality data becomes a critical component of being able to discover otherwise hidden issues buried in complex architectures. So you're taking a very high dimensional data, right? Like million key value pairs, and then you're comparing it with high cardinality data, basically processing it. So let's say you got like 100 key value pairs, you have your cardinal data, you identify the cardinal data, analyze the cardinal data with, so all the dimensions are reduced in terms of cardinal data, and then by analyzing that data you can tell, okay, this state is going to, basically kind of go wrong, it's going to basically degrade, or it's not been doing well, its health is failing, and you can get to the problem before it happens. Or if the problem's already happened, you can tell, okay, this cardinal data, this is the unique data, this unique data is only here, and hence you go and get to it, right? I'm glad you added the sarcasm. Thank you. All right, folks, does that make sense? Hi Roshan, welcome to the stream. All in the same page, folks? Everyone same page? Any questions regarding what I just said regarding cardinality, dimensions? Working on it. Alright, take your time. I'm gonna give you all exactly 3 to 4 minutes to process it. It's a very short stream today, but just discussing it. I think most of the time the next 2 slides are literally about discussion, so I am sure you all will catch up. Oh yeah, I'll send you the link to the book in just a bit. Most of the content from here and my flashcards that I made are all from this book. I am genuinely loving this book. I'm not through with it entirely. I'm still left with some of the last part, but great book to start with in observability. So the thing is, I just wanted to understand how how much you all are interested in it, because one of the GHWs, I created a lot of hands-on content, and turns out people weren't that interested in learning the hands-on end of it, which is why I haven't created anything hands-on for both streaming databases and observability. So if you all are, let's say, Vrinda's already worked on open telemetry, so I know that you all, and this is good, this is actual stuff that you all use once you go into companies, right? So if you all join a corporate or an MNC, you will be working with Kafka streams, you will be working with some form of telemetry data, right? It can be a simple telemetry data only for a specific entire service in your tech stack, but it's nice to kind of have a way with it and have a gentle understanding of it. So if you're like genuinely interested, I'm happy. Next year's chapter is anyway data engineering, so we can definitely cover a lot of hands-on. We can have an entire streaming database track and an observability track. Oh, I already decided who got last. There is no swag drop in this session. I did a swag drop in the last IoT session, and yeah, Gaming Skull apparently won it. We need to create a ticket for him, but yeah. I hope you all completed the task though of connecting the MQTT to the LED. Would you like to, Brinda? That would be amazing. Have you created a Discord ticket? Create a Discord ticket and just tag me. I am just keeping an eye on Discord in case you create a ticket. And if you can't create a ticket, just DM me. I will send you the link there. No worries, Brenda. Just DM me on Discord. You'll see me in the announcements channel if you can't find my user ID. Alright, folks, any questions at this point? This is the crux of observability, right? These are the points if you all know, you all are already ahead in the game, right? If you see a lot of tutorials that follow open telemetry or anything, no one talks about the theory behind it, right? What are you sending to the open telemetry? You can copy paste code and the thing will work, but this is the basic theory behind what's happening. You're basically what data you're taking, how you're processing it, and just send me a DM, Brinda. I'll teach you how to. Or do you want me to show you how to create a ticket? Which one would you like me to do? Okay, Brenda, you can go to this link. Oh, you DM me. But just for future reference, try going to this link that I've just sent on Discord and creating a support ticket. And tag me once you do it, and I should be able to see it. Alright, Brenda, I've sent the link to you. Let me know as soon as you join. Alright, folks, does the I see no one is profiling comes under observability. What do you mean by profiling here, Roshan? I'm sorry I missed your question earlier. There'll be a ticket created in his name soon. No worries. I'm glad you have questions, right? Folks, any questions regarding this entire slide though? There's a lot of chaos on this slide, I understand, but any word, anything that I explain that does not make sense, or you all would like me to explain again? Hi, Brenda.
Hi, hi, can you hear me?
Yep, I can hear you. Do you want to turn on your camera really quick?
Uh, I'm in my
It's
office
okay if you're not.
actually. Yeah.
It's okay if you're not comfortable. No worries at all. Great. So tell me, when did you use open telemetry data? How did you understand observability when you used it for the first time?
Yeah, sure. So I just used it last month actually. Last month is when I learned about observability and you how to use it for. So we had a complex Java microservices project which we wanted to enable open telemetry so that we can know what is going on inside it and where the bottleneck is if it fails or whatever happens. So that's when I tried to incorporate OpenTelemetry into our systems. I mainly went through the went through their official documentation, and that's from there on I got a fair idea how to use it and all. So to start with, I tried automatic instrumentation first in OpenTelemetry, and then to customize things, I also used the manual instrumentation so that we can have custom attributes inside our traces, which would be very useful for you know um, checking what went wrong and for which of the applications it went wrong inside it.
That sounds
And
very interesting.
yeah, and it also was very nice to see that using automatic instrumentation, I didn't usually actually had to change a lot of code. I just had to make some minor changes, and everything else came out of the box. So like services like HTTP services or MongoDB calls or Kafka services, all of them were automatically instrumented. I didn't have to do anything for them. So that was one good feature I found.
That is awesome, Brenda. So, okay. Do you want to first introduce yourself? I always forget to introduce myself and people who join the stream. So, do you want to do a quick introduction about you?
Yeah, I'm Vrinda. I studied computer science at College of Engineering, Pune. I just graduated last year, and
Oh, wow.
yeah, and
That
I've
is
been working
awesome,
in
Linda.
GS. Yeah,
And where are you working?
Goldman Sachs
That is awesome. So, you're in Bangalore or still in Pune?
in Bangalore.
That is amazing, Vrinda. I actually went to college in Pune myself. So, that is amazing to
Oh,
hear.
which one?
I went to Cummins College.
Oh, that's great. I had a lot of friends there.
Yep. So it was great though. That is amazing. I'm so glad to hear about that. And yeah, is there anything else you want to share? And just out of curiosity, the stuff that I just explained about cardinality and the high dimensions, does that help in your understanding with the observability that you did, that you implemented?
Yes, that did. To understand the basics uh, in the first stage, this would really help initially. Yeah,
I'm so glad to hear that because the thing is, theory is always difficult to deliver, right? Because it's so
yeah,
easy to
yeah.
lose attention. But I'm so glad, Brenda. I would love to collaborate with you for the data engineering stream as well. So you already DM'd me, so we might have Brenda back. And in the next GHW to help us with observability. Yes, Brenda?
Yes, yes, sure, sure.
Thank you so much, Brenda, for joining us. Maybe next time we'll give you a better, heads up so you can have your camera on.
Yeah,
But
yeah.
I'm so glad
Sure.
you took the time to
Thank
join
you.
us.
Yep, yep. Thanks.
Awesome, folks. Reach out to Brinda if you have any more questions about observability. She's done way more hands on. I'm more towards the studying side right now. So by the time we get on to GHW data engineering, I'll have better idea as well. And I will, of course, be pestering Brinda until then. So we'll be back at the data engineering week. Brinda, is it okay if I remove you from the stream now?
Yeah, yeah, sure, sure. Thank you.
Awesome. Thank you so much for joining again. All right, folks. Uh, Last couple of slides left. Again, a couple of really bad examples, but funny examples, so you all can remember what's happening. And yeah, and then we can move on. Again, folks, I don't see any questions from this slide, which is a little concerning to me because it took me a really long time to wrap my head around these concepts. And I hope you all take the time to, really read through the book link that I sent. And of course, these sentences are basically the crux of the entire thing. I actually went through it and extracted four sentences that make sense. All right. Roshan, that's a great question. I haven't heard about or used profiling just yet, but I am happy to look into it and see how it's different from the logs that we're talking about. But here's the thing, what observability is doing is it's taking all of these things and then processing the data to kind of give you all the unique data against the anomalies, right? So there's a high chance that you're using profiling when you're using observability and sending all the data to the open telemetry data, or using it, to send more data to your final processing point. Amazing, Shimari, and I have no doubt that you'll actually do it. Yes, Surinda did an amazing job telling about how open telemetry has helped her and how she's used open telemetry in her work space. Thank you, Anudhan. I am a little. It's one of my proudest achievements. I bought this stuff, yes, but it's still an achievement to me. All right, folks. Last two slides, and then we can wrap up. I told you, and I promised you, it's going to be a short stream, and we're going to stick to that. Okay. Another bad analogy, but I actually had fun coming up with this one. So you know how students in your schools, when you're actually in the classroom, your teacher will ask the students, your peers, to monitor you, but the teachers are always observing. Now I know it's a fairly cringy analogy, but stick with me. Okay, so the more highly dimensional your data is, the more likely you'll be able to find hidden or elusive patterns in your application behavior. All right, so the permutations of failures that can occur can be effectively limitless, right? Because you have tons of key value pairs coming in, right? So capturing only a few basic dimensions of your telemetry data isn't insufficient. Remember, that is why we're sending all the logs we possibly can, right? So you must gather incredibly rich detail about everything happening at the intersection of your users, code, and your systems. So high dimensionality data provides greater context about how these intersections would unfold. The higher dimensional your data is, there is a high chances of, even though the cardinality overall will be low, there will be high cardinality once you take out all the data which is causing the problems, right? I'm glad you agree with me, Anityan. Does this make sense, folks? So monitoring is basically, just going to tell you in the point, and then you'll have to go back and look at a lot of data. But when you're observing a lot of things and a lot of values before you're coming to a conclusion, or you're, pointing someone out. I see no comments about the analogy, so I'm a little relieved and offended at the same time. But yes, this is something that, that's something you won't forget, right? It's something so weird and out of the blue. Alright, so how do we make a system observable? This is again a very theoretical approach, so I'm going to quickly cover it. Instrumentation. What's instrumentation? Basically, the first, okay, so we're talking about sending so much data to, our processing part or our backend, which can actually tell us what's happening. But how do you send this data? There has to be, you can't have another entire tech stack engineered in your team to be able to send and collect the data, right? So there's something called instrumentation, and open telemetry is very highly used in that, to basically send all this background data, all this, tiny key value data to wherever you wanted to basically collect. Right now, you can send it directly to Grafana, you can send it directly to your visualization software, etc. Right? But instrumentation is a huge part of making a system observable. All right. Next is data correlation. Right? You need, then after that you need to sit down and get another stack, or use another tool to correlate the data. Right? Taking out the patterns, extracting the data that actually is useful, and ignoring and basically getting rid of any data that's repeating and not really relevant to, if things are working fine, there's a lot of repeating data, you don't really want to analyze it anymore, right? So you want to take out the data that's actually need to be analyzed. Then it's incident response. Okay, there are two ways to incident response, right? That there could be problem happening and you've been pointed out kind of sort of the error point in the code, which is great, which is a great start, because imagine having like tons of microservices and having no clue where the error is starting out, or what state is actually failing. So incident response is easier, but it still responds to an incident. Observability also gives you an idea of where an anomaly might occur in, a few states, or in a bit, and that bit can be very short span. Okay, error is going to happen now, and the error happens, and then you go and fix it, right? So being able to respond to the incident is important in a system that is observable, right? You're not just observing, you're also responding it in as a part of observability as a metric, right? And then there's something called AI ops, right? I told you it's kind of related to DevOps, like this entire thing. We usually platform engineers end up, having to deal with it. So AI ops kind of helps you do the incident response even faster. So it's something that can be fixed by, studying behavior of the past incident responses. It can be easily implemented. All right, folks. So let's talk about this. Right now, this is very optional. Observability with respect to DevOps, SRE, and cloud native. None of what we just talked about means replacing any of these. Right? None of what we talked about is actually supposed to, make any of these specific things easier. Everything that we spoke about is kind of, to smoothen out the communication between this team and the rest of the, entire tech stack, right? Because most of the time, if you're, it's failing, it's not the code that is specifically causing the error, it's code on top of something that's causing the error. So observability in respect to DevOps, SRE, and cloud native helps them kind of, become the people who communicate better with other, like we said, that question that we asked, who is supposed to deal with the problem when it occurs? The user, just to get them used to the problem, the application engineer, which is basically the person who's writing the code, or the platform engineer, which is basically, resourcing or allocating resources and keeping an eye on, whether every deployment is working well, right? Because most often than not, if a code fails, and then there can be a deployment issue in the chain, so everything is kind of interlinked, right? So observability really helps smoothen out the communication between DevOps, SRE, Cloud Native, and their entire teams, right? Instrumentation with open telemetry. All right, folks. I'm gonna stop sharing the screen. This is basically the last slide, right? You all can connect with me on any social media platforms. That's that you all already know. I'm going to quickly take you all over the OpenTelemetry website, show you how vast it really is, because we'll be eventually using that in our next sessions if we end up doing a track, right? So let me quickly pull up that. And while I'm doing that, let me also quickly share the link with you all to the book. So give me 1 second. So this is the link to the book. And I'm going to quickly take you all over the OpenTelemetry website. So present, share screen, tab. We're going to have to share a window. So there we go. Alright folks, can you all see my screen? Alright, so this is your OpenTelemetry website, and this is pretty big, right? I mean, you all can see that, like, just getting started, there are two options: there's dev and then there's ops. Let's see what's the difference, right? So developers, you're basically being given these options, right? So if you develop software, this is the OpenTelemetry that you need. If you're an ops person, we just spoke about how it's a little different for DevOps. You're going to have a different way of getting started to basically be able to deploy OpenTelemetry to your platforms, your deployment end of logs and traces, right? So let's look at demos. These are all the demos. You all can just basically go here and start implementing it and looking at the amazing diagrams that they've created, the architecture. So you all can see, right, how complicated the architecture is. You have email service, payment service, currency service, ad service. There's a front end proxy. There's a front end HTTP. So you can see how where you're actually adding your entire layer of collecting the entire data. So you all can imagine all these services. Every service has this entire structure being given to it. So there's the OpenTelemetry demo, which is one single microservice that they're showing how the data flows, right? So Prometheus, then Jaeger, they're all extra, tools and tech stacks available for you all to, and make the entire system more observable. All right. So this is the thing, and you all can just go ahead and just kind of follow one of these tutorials to just get started and understand the basic crux and the basic, background of what's happening. You don't need to understand everything. And then there's a lot happening. Then this main thing is concepts, right? So what is observability? Signals, what are the types of telemetry supported by OpenTelemetry specifically? If you need something else, you might have to go find another telemetry tool or instrumentation tool, right? So this is what we spoke about, right? Facilitates automatic and manual instrumentation of applications. Then there's components, main components that make up telemetry, not observability. All right. Then there's a lot of things that's happening here. So this is a great website to go through because OpenTelemetry is definitely the standard, right? A lot of places you will see OpenTelemetry is the default standard, right? So it's a great way to get started with OpenTelemetry. Oh yeah, that's the link. Thank you so much for sharing it. If you all want, I'm going to quickly share it again. So this is the main website that they have that you all can look at. And if you just click on docs on that is where Shimari is sending us, and that's the correct link. Let's share it again just in case. All right, folks, that is it. It's a short session, as I promised, and we just spoke about a very basic and a very gentle intro into what observability is. But we spoke about the core concepts, which, in my opinion, are fairly important because if you understand what's really happening, it's easier to debug that also. Because setting it up is no easy task in terms of getting the tiny things right. All right. All right, folks, are there any questions that I can answer for you all related to the stream or to GHW in any way? You all have been pretty quiet today, but then I expected you all to be much more quieter because it is the last day and it is a Monday morning in India. And I know it's very late for Shimari. And thank you so much for sticking around, Shimari. All right, folks, since I don't see any questions coming in or any, comments, I am going to start closing the session. No worries. I'm glad you enjoyed the session. And Gaming Skull, you'll get a ticket soon in your name. So congratulations on winning the swag drop. Great job on the MQTT project, though. Best of luck, Shamari. Sounds like an exciting time. Wait, are you in high school, Shamari? That is so cool. All right, folks. I had a great week with y'all, and yeah, I'm so glad we did. I had so many streams. This is, I think, the most streams I've taken in a GHW. I think I had almost like 5 technical streams. Alright, no, I was just curious because usually college in the US starts in August, so I was just wondering. Yep, see y'all, and I will talk to you. I'm of course on Discord, and if I start a hackathon, you all will know. But yeah, I will see y'all very soon, preferably, most probably in the next GHW than any hackathon. But that is so cool. Best of luck then. I hope you enjoy your classes, and I will close the stream. Thank you so much for joining me through the week. I will see you all in 3 weeks. Bye, folks.